Welcome to our third and final video for Module 1 through Week 1, which is sections 1, 2, and 3, or chapters 1, 2, and 3. I'm going to use those interchangeably. This is going to be a little bit shorter. I think the very good thing for you to do is continuously watch the video. These slides are just a brief introduction to what's in these videos. So a lot of this would be duplication. The videos explain these in great detail. Please remember that you're free to put the videos on a little bit higher speed. You can put them at one time, 1.25, 1.5 times. Watch them in ways that you feel the most comfortable. Go back and watch them as often as you want. I have watched every one of these videos in Week 1, and I think they are absolutely outstanding. So we're talking about network adapters in here, and these are terms that you need to know: NIC, GIBIC, SFP, XFP, MAC address resolution, which is ARP, and reverse. And mostly you're going to hear NIC as a network interface card, and the others are going to be explained in the upcoming slide over here. So a network interface card, and this is what you use to connect the cable to the actual network, whether it be Cat5, whether it be fiber, or something else. GIBIC is an interface converter, and it plugs into a switch or a router, and that's used for gigabit media. It's actually being outdated and being replaced with different types over here. And you can see SFP, small form factor, and again, pluggable, and XFP is a transceiver similar to FFP, but it's used for 10 gigabytes. MAC address, we already talked about MAC address. That is the 6 pairs of hexadecimal. It's used to uniquely identify an object, such as a NIT card. The first 3 are the manufacturer. The last 3 are the actual network card itself. ARP, which is Address Resolution Protocol, and you're going to be using that when it tries from one computer to connect to another computer to discover who it is. You're going to find ARP to discover the MAC address from an IP address. And of course, reverse ARP does the exact same thing. It's going to find the IP address from a known MAC address. Each computer and switches are going to create a MAC table. So here you have a computer needs to print over a UDP, unsystem twisted pair, over the Ethernet, doesn't know where to go. It needs to send out signals in here through the NIC, and through the modem it would be analog. Then we have the SFP to connect. This is a media converter, and you can see how it's got 2 different types of connectors. One is Ethernet, Cat5e or Cat6, and the other is going to be a fiber. MAC address we already talked about. Data flow, this is how it works. It goes from application layer to application. Remember, application or protocols such as HTTP, HTTPS, POP3. So you can see it goes all the way down to the network, and you're going to have a destination source in both of the capsule and the data itself in the capsule. So it's going to determine where to go from that. You can see down in the data link the actual packet that was in the network, and the layer 3 gets put down in here along with the destination and the source. So you can see it uses the MAC to determine the IP address, and it sends a broadcast to get the information from where it's going, because it does not know that. All of a sudden it finds the IP address over there, and then that is actually going to get stored. Here is a simulation that you should be doing. Okay, and some class discussions. I highly recommend that you stop, pause the video, and that you look at these things and that you try to identify each and every one of those. Again, more class information. The network devices, here's a simulation for you to do. Hub, bridge, switch, and wireless access point. Hub is old technology. It's one where data gets sent from every port trying to determine where it needs to go to. The problem with it, once it finds it, it's going to send the same information out again and again and again every time 2 computers try to communicate. So you can see a hub. A bridge is something that's going to connect 2 or more media segments on the same subnet. However, it does a little bit more efficient by keeping the segments separated whenever possible. Switch is multi-port, and it's going to do the same thing as a hub, but it's smart. It knows, hey, I know that computer B is on port 4, so when I get a request to go to computer B, I'm only going to send it to computer B. In the beginning, it acts like a hub and sends out information on every single port, with the exception of the one that was used from the source computer, because obviously that's not where it's going. But then once it learns where it is, it keeps track of that. So the next time somebody tries to send information to that computer, it knows exactly where it is. Okay, and wireless access point we'll go over in a little bit. Okay, a hub is called a repeater because it's going to constantly repeat the same thing. So we have a message sent from one computer going to a different computer. The hub has no idea where it is. It sends out a request on every other port. And here we have it. It finds the port, again, layer 1. So now we have multiple hubs. This is even less efficient because now it's going to be sending out the same information on 8 different ports instead of 7 different ports, or rather instead of 3 different ports. It's not going to send it out on the one that originally came from. So now we have information's being sent, doesn't know where to go. So the first hub is going to send it to everybody on the network, boom, and then it's going to send it out to everybody on the other network. It has no idea where anything is. It's just going to send everything out to every available port. And then, boom, it's going to get sent to all 7 computers that are not the original source computer. A bridge is going to be basically the same thing in the beginning, but if it knows that the destination is on one link, it's not going to send it to the other link. So if it's going into one of these 3 computers here, it's not going to get forwarded because it's going to learn that. If it's not, it's going to send it to the next hub who's going to do the exact same thing and just forward it to everybody. So again, you can see how this works through the data flow. It needs the MAC destination, the MAC source, and all the data is in here. So you can learn about this in the video in great detail in here. So bridges are layer 2 devices in here. So we'll keep going through this over here. A switch is a little bit different. A switch will learn where a computer is. It will store it in its table. And so if network A is going to go to network segment D, it's going to keep track of that and only send it to segment D on the next time around. So again, the forwarded databases are built and only forward the necessary data. Wireless access points, many of them are going to connect over here. You do need to have one Ethernet cable that's hard-coded into the network itself. You can block any particular MAC address that you want if you feel that somebody is trying to constantly connect to your network and you don't want them. You can do that through MAC filtering. You can also do it the other way around. Say you have a computer in your house and you only have 3 phones, you know their MAC address, you want to stop other people from being able to connect, you can do MAC filtering by only allowing these devices in here. Okay, unicast and broadcast, you can see that inside the video. Just remember, FFFF, all Fs, is a broadcast. Here are simulations for you to do, more class discussions, and another simulation. Router, firewall, and layer 3 switch. A router is an instrument that operates on layer 3. It's going to have 2 separate networks that get connected to 2. So anything that goes to another network will get routed there. A firewall is a piece of equipment that blocks traffic going out or blocks traffic coming in, depending upon what's needed. You'll see that in a minute. Layer 3 is nothing more than a router that has multiple ports in here. So again, a firewall is a router with additional security features, and it can be programmed with security rules to restrict flow of traffic between networks. Your firewall is what goes out to the internet, the very last device in there. Again, a layer 3 switch is basically the same thing as a switch that allows routing. So you can see we have a router here and it has 2 separate subnets in here. And then we have the WAN itself. So we have to be very careful what goes out to the WAN. You may want to block online gaming. You want to block these different categories. You can block specific websites from going out. So your users can only do company business if that's what you choose. And these things are done by categories. So online gaming, anything that sites that has any kind of gaming will get blocked. You can override that if sometimes a site that you need gets blocked. For instance, you might want to block all online shopping, but you do business with Amazon. So you can open up Amazon as well. And then the switches don't have the blocking capabilities that the firewall does. So again, you can see how the routers can connect individual networks in here. And you can see again, it's going to, in the layer 2, it's going to put in the packet itself from the source and the destination. And you can see that in the video, which explains it step by step. Here is a simulation for you to do. And we have, again, some more class discussions. And that's it from this one. Hope this was informative for you. So if you have any questions, please let me know.